Okay, so let's have a look at this table here. Okay, the major differences between non-alcoholic and alcoholic liver disease is the difference in their ALT AST ratio. Okay, so now I thought ALT AST are enzymes which are present in hepatocytes, right? So when there is hepatocyte damage, these enzymes will leak out, their levels will rise in blood, and that is going to happen in both these conditions, right? In both these conditions there is hepatocyte damage. So this just looks like such an internal inconsistency, right? Like, why is the ratio different then if both of them are leaking out ALT AST due to hepatocyte damage? Then when I looked for an explanation, I was told that AST rises, right? But ALT rise is blunted as it requires vitamin B6 to act. And vitamin B6 or pyridoxine is deficient in chronic alcoholics due to malnutrition and other factors, malabsorption. And that is why AST to ALT ratio will be more than 2 in alcoholic liver disease and less than 1 in non-alcoholic liver disease. Okay, so then I thought, right, vitamin B6 is required for the action of ALT, right? But the amount of ALT that is released in the blood, that is still going to be high, right? The rise of that is not going to be blunted. It'll just be functionally inactive because it requires vitamin B6 to act and vitamin B6 is deficient. So I was like, how is the ratio this then? Like, I was just completely confused. And so I really kept looking for answers. And the actual explanation was something so simple that I did not even imagine how I had missed it. Okay, so now let me give you the most important intuition in biochemistry I feel that you really require. Okay, so let's now truly think like a biochemist. Okay, so when you measure the amount of ALT and AST in the blood, what I earlier thought was you were measuring the physical mass of the enzyme in the blood, or like the number of molecules that are present in the blood. But that is not the case. IU, which is the unit, it is the international unit of activity. You're measuring the activity of the enzyme. Okay, so the amount of ALT AST in blood is measured by how fast these reactions can happen, right? This is the mechanism of ALT AST, right? Transamination. So if this reaction will occur at, let's say, X amount of speed, then you can conclude that this can mean that A amount of ALT is present, right? So it doesn't actually measure the physical mass, but it measures the activity of the enzyme, the speed of the enzyme, the reaction happening, and that is how you just imply it to the amount present. Okay, because simple, right? Amount of the enzyme is directly proportional to the speed of the reaction that is happening. So more will be the amount, more will be the speed of reaction. That is what we thought in simple cases, which is why probably the mass of ALT in the blood, the amount of molecules of ALT present in the blood must be high. They must be even higher than AST. But the activity is blunted because it requires B6 to act. So when you measure, when you put the plasma, when you put these reagents and you subject it to the plasma of the patient, you have ALT, you have lots of ALT, but you don't have B6, and which is why this enzyme won't work, it won't occur that fast, and then you will kind of wrongly conclude that ALT is present in less amounts. But that is not the conclusion. That you have to understand that the activity of ALT is reduced. You're measuring the activity, not the mass. Okay, so yeah, I hope this is clear, and thank you. So lage haath, let's just understand the enzyme profile that you will get of a chronic alcoholic baba that will come to your ward. Okay, so we've understood this part, AST to ALT ratio more than 2. I don't think you will ever forget it. Now let's come to the other two. AST will be less than 300. Now this you will have to look for a little, because more than 300, think of viral or ischemia or toxin as the etiology. Okay, because see, now let me explain what happens. ALT AST are not coming into the blood because of bursting of hepatocytes. Okay, alcohol just causes hepatocyte injury, makes the hepatocyte leaky, which is why enzymes leak out. Okay, so that's why the level will not be too high also. But if you're getting a level more than 300, this is a lot of AST, mind you. you have to think of very severe damage which is causing hepatocyte bursting, like all of these etiologies that I told you. Okay, so this is just a little thing that you need to keep in mind. If AST is less than 300, it points towards alcohol as the etiology. Okay, but more than 300, you have to, it kind of rules out alcohol. Okay, now high GGT. Now we often learn that GGT is present in the bile duct epithelium. So how is alcohol causing, how is it related to anything bile? So no, GGT is also present in the hepatocytes. It is mainly present in the microsome of the hepatocytes. Okay, understand this. Alcohol increases it's basically a microsomal activator, right? So it increases all the enzymes that are present in the microsome, which is why GGT is increasing. You don't have to think of GGT rise as damage to the bile epithelium, and that is why the GGT is leaking out and all. No, that is not the case. Alcohol is not causing GGT by that mechanism. It is just activating the microsome. Microsome will produce more GGT than normal. That is why there will be a rise in GGT. In fact, GGT is the most sensitive marker of a chronic alcoholic. Okay, so if you're getting raised GGT, you first have to think of alcohol. Okay, so I hope you like it. Bye.